Hello and welcome back to Calculus 2 after all this time, sponsored by the stupid spring break and snow. However, I know I did see you last week, which was awesome, at least half of you, which is nice. Today we are going to travel back in time and unite our integration with some serious middle school skills. We are going to take the area under the curve, break it into rectangles, break it into trapezoids, break it into some weird shapes, and compute values of integral that way. You already seen this to some extent in Calculus 1 on the way of learning, on your way to learning Riemann integral. So what you had is, let's say, square root of x function, and you want to calculate the integral, let's say, from 1 to 4. That's your job, of square root of x dx. Now, you know how to do this by hand, obviously, right? You take the integral, which is x to the 3/2 over 3/2, and then you compute that at 1 and 4, and you're done. But we can also solve this numerically. And I'm going to do that by creating these 4 regions. I have a equals to 1 and b equals to 4. So I have the 3 rectangles. Well, they're not rectangles yet. They will be rectangles. And I'm going to define a left point for now as the important point, and I'm going to do this approximation by drawing in blue these rectangles, and I will call this the left-hand approach. So area L, which is the left hand, is clearly going to be the function computed at 1 times the delta x, which is the distance in between two numbers, in this case it's just 1, plus function computed at 2 times delta x, plus function computed at 3 times delta x. Now this is all from Calc 1. We are reviewing right now. And we can now compute these values. So we have square root of 1 times 1 plus square root of 2 times 2 plus square root of 3 times, times 1 times 1 times 1. There we go.